Hi, this is Quinlan. I am creating this video for Project 1 for Introduction to Machine Learning. On the left here, you can see that I have uploaded my data sets. I'm going to go ahead and run the code. You can see that I print the output for every individual fold. I've done 5 folds here. And then I also print the average classification accuracy or mean squared error, depending on whether it is a classification or regression task. So here is the car data, 5 folds, printing each one, and then the average, cancer data, voting data, abalone data. So now we switch to regression. You see that it's MSE instead of classification accuracy, forest fire data, and the average, and then machine data, average, and then the 5 folds. So going to my process for the cross-validation, K is a variable. You can change it. Fractional test is set to 8.2, but that could also be updated. I then loop through the K buckets. The K buckets are split here using that input K. I create my test data using a sample of the data set, where that sample is the fraction test set here. The training data is everything but that fractional test data set. And then if it's classification, I calculate the mode of the class column and then pass that to my classification accuracy function. And if it is regression, I calculate the mean and pass the mean to my mean squared error function. And then these functions print out the output that you saw earlier. Here is the average printing that you saw earlier. For the cleaning of the data, for the cleaning of the cars, we replace string data that has ordinal relationships with the corresponding ordinal values, and then we just take that dictionary and we do a data replace using the dictionary in place equals true. You'll see that this is how I do all of the ordinal data. For the machine data, I go ahead and drop the non-predictive columns and then the calculated column from the previous study. And then I do discretization. So any class values between 0 and 20 are assigned bin 1, 0. Anything between 21 and 100 is assigned bin 1, etc. Anything for the class that is a value above 600 or equal to 600, above 600 is assigned to bin 7. So then we have the forest fire data. We go ahead and drop the first row because that is the column names and we don't want that. We do the ordinal data replacement, 0 through 11, 0 through 6 for months and days. And then the area of the fire, which is the class, skews heavily towards 0. And so we do a addition on it and then a log function on that addition so that we have more usable data for the class column. For the cancer data set, we drop sample code number because it's non-predictive. We replace all of the question marks in the data with NaN, not a number, and then we calculate the mean, skipping all the not a numbers. This is imputation for missing values. And then we replace the means of each column. Wherever there's a question mark, it gets the mean of the column instead. Again, that is imputation of missing values. And then for the abalone data, we did one hot encoding. So we're taking the sex column, we split it into 3 different columns, male, female, infant. If the original sex column is male, male column is set to 1. If the original is female, female column is set to 1. If the original is infant, infant column is set to 1. And then the remaining 2 columns are set to 0 respectively. And then we drop the sex column because we're no longer using it. For the clean voting data, once again, we're just assigning numerical values for non-binary data. And then here we have the mean squared error, the classification accuracy functions. We just use the definitions in the report. And then I have the z-score here. It had a nice plot going, but I accidentally changed it to series data instead of a data frame, which broke my function. But it should have been test data minus the mean of the training data divided by the standard deviation of the training data for each column, and then the KD plot would have plotted those against each other. And that's it.